Hello, hi, welcome to the new video. Here we are starting with OWASP Docker Top 10. As earlier video, we have covered Docker security basics. So to deep dive into that, how the web API top 10s are there. Likewise, Docker Kubernetes top 10s also there. So as a part of that, in next upcoming 10 video series, the OWASP top 10 for Docker will be discussed one in each video. For getting more information about OWASP Docker top 10, you can directly search with OWASP Docker top 10. So this will takes you a link where a GitHub URL is there. Here you will get a GitHub a URL, and in this you can see what are all the OWASP Docker top 10. Like it was indicated with the code D01, D02 like this. Okay, so these are the different vulnerabilities in a Docker, and there is a PDF also here. If you see here, uh, this particular PDF says the what is the list in the OWASP Docker top 10, and some explanation is given here in this particular video. As a part of that, I worked on this and I did some research also. So I prepared a consolidated kind of presentation. By that you will clearly understood what exactly the OWASP Docker top 10 and what exactly the particular codes and what includes in that particular codes and what is the risk and associated solution and best practices for each and every OWASP Docker top 10, and what if we ignore those particular vulnerability, what may happen. Okay, so all these things will be discussed in this particular video. So without further ado, let's enter into the particular video and have a discussion around this particular thing. Okay, so first thing was D01, which is Docker OWASP top 10. Okay, and the name of the vulnerability was secure user mapping. Okay, so here the risk associated in this particular vulnerability was running containers as root can lead to a host system compromise. What exactly this particular risk was? By defaultly, if you see, many containers run as a root user that's having a UID 0. Okay, basically user ID 0. So this is very dangerous because if an attacker exploits a vulnerability inside the container and it's running as root, they could like potentially break out and gain a root access to the host system. So that's like giving a stranger's full admin rights to your particular computer. Okay, so the associated solution for this vulnerability was we need to map the containers users to non-privileged host user to limit the damage or exploitability. This particular solution is simple but very powerful. Basically, don't run your containers as a root. Instead, we need to map the user uh, in a container. So, internal user to a non-privileged user to the particular host. Okay, so that particular host, that particular internal user will be used in the whatever the commands we are executing in the host. Okay, so within the container, not in the host. So basically this particular like solution limits what the container can do, and even if it's compromised also, uh, there is no much effect. Okay, it's like giving your guest access to a particular living room in your house only. Okay, instead of entire your house. Okay, so coming to the best practice, we need to make sure to use a user or directive in Docker file to avoid UID, that is user ID 0. In your Docker file, always use the user directive to specify a non-root user and avoid UID 0, which is basically root user, and you can create a user during the image building and switch to that particular user. I mean, if you see in the Docker file structure, we are going to write a from. After that, we are going to run a command. In that particular run, we need to use add user. Okay, run add user hyphen m, and what is the username we need to specify, and then we need to specify the user derivative. Okay, so in this particular user derivative we need to specify whatever the username specified here, that should be specified in the user directive. Okay, so this will basically ensures the applications runs with limited privileges, reducing the radius of attack effect. Okay, so and coming to the main important point, what happens if we ignore this particular vulnerability? Okay, so basically if you ignore this particular vulnerability, I mean this particular user secure user mapping, and run your containers as a root, um, there might be a chances of getting a privilege escalations where attackers can gain a root access to the host mission, and they can also get a host file access. There might be sensitive files like password or some root folders, so that will be exposed, and there will be a possibility for malware installations also, like attackers could install a malicious softwares on the host mission, and chances for container breakouts, especially in older kernel or some misconfigured environments especially. So this is very much important, that is a secure user mapping. Okay, so moving to the next one, that is patch management strategy. Okay, so the D02, which is a Docker vulnerability. Second one, that is patch management strategy. Okay, what exactly the patch management strategy was? The associated risk in this vulnerability was there will be a outdated base images contain known vulnerabilities. Okay, so every Docker image is built on a certain base image like Ubuntu, Node, Python, etc. These particular base images often contain some system libraries and some packages. So if they are outdated, the libraries and packages obviously may contain some vulnerabilities that attackers can exploit. So if you see a non-technical example for this patch management strategy containing a vulnerabilities in the outdated packages, it's like building a house on a cracked foundation. So we know there is a vulnerability which is cracked, and again also you are building the house. Okay, so definitely you are in a trouble in that particular case. Okay, so in that particular case, the what is the solution? Solution was we need to regularly update the base image and scan for your vulnerabilities. So this particular solution is proactive, where we need to update the base image regularly. Don't just build once the image and forget and use it. Use some vulnerability scanners like Docker Scout, uh, Trivi, and basically that will checks the I mean that will scans the Docker images, and if there is any known CVEs are found, that will be highlighted. And coming to the best practice, we need to automate the updates and use the minimal base images like Alpine. Automatically, I mean automation is key here. Okay, so uh, by using a CI/CD pipelines to rebuild images periodically, and integrate vulnerability scans into the pipeline, and also perform some minimal base images like prefer using the minimal base images like Alpine, and like lightweight images we can say. Okay, so basically that will have a fewer packages, which means the attack radius also will be reduced. Okay. And coming to the like what happens if we ignore this particular patch management strategy in the Docker image or file. In this particular case, there will be a chances for known exploits, like attackers can use a public CVEs to target your containers, and compliance violation also may happen, like outdated images may violate the security policies, and zero-day exposure will happen. Um, basically, in short, we can say outdated images are like some expired medicines. So they might still work, but they can also make things worse and may not work also. Okay, so that is the about a patch management strategy. And coming to the next one, that is D03, which is network segmentation. In the name itself, it says network segmentation, where we will be focused on container networking and how and why the segmentation matters. So the risk associated here was containers can access unnecessary network resources. By defaultly, if you see, the containers may communicate freely across the network, uh, like a bridge, by using a Docker bridge network. Okay, so this can expose some sensitive services or allow some internal movements if one container is compromised. So it may cause problems to the other containers also. Okay, and the associated solution for this particular network segmentation, like access to the unauthorized networks, was using implementing a network policies and disable inter uh, sorry, I was reading the best practice in the solution part. We need to use some custom networks and firewalls rules to uh, restrict the access. That means we need to create some isolated Docker network for different services, and we need to apply a firewall rules to control which container can talk to each other. Basically, this will limits the exposure and attack paths also. And coming to the best practice, we need to implement network policies and disable the inter um, container communication. So to achieve this, we need to use like there will be a argument in Docker commands, like hyphen hyphen ICC is equals to false. Okay, so basically ICC is nothing but inter container communications. If by default it will be true, and if we specify explicitly hyphen ICC is equals to false, that will basically block the inter container traffic, and we need to apply a network policies by using tools like Calico, we can say, which is available in Kubernetes environments. So this enforces the strict communication boundaries and safely usable. Okay, so and coming to the like what happens, what goes wrong if we ignore this particular network segmentation. So by ignoring the network segmentation, it will allows the attackers to move in between the containers across the internal services, and potentially may compromise the entire application stack also. There might be a chances. Okay, so that is all about the network segmentation. And moving to the next one regarding D04, which is secure defaults. So in this particular secure defaults, we are going to see how a default Docker settings can silently weaken. Can we provide? Can weaken your container security? That means it may. provide some weakness to your container security. And the associated risk was a default Docker configurations can often insecure. So a Docker like out of the box, which is the Docker priority. Basically, the Docker prioritizes the usability over security. This means many features are enabled that may not be needed, and that could be exploited also. So that is the associated risk with this secure defaults. Okay, so if you don't secure defaults, and the associated solution for this was we need to harden the Docker daemon and container runtime settings. So here we need to review and log your Docker daemon settings, and we need to disable risky options, especially like argument in the Docker commands hyphen privileged, and strict capabilities, and enforce secure runtime parameters while using a commands especially. Okay, and we need to follow some best practices, that is disable unnecessary features, enable some security options like app armor. So we need to use Linux security models, like whatever the app armor is there, that is the Linux security model, and SE Linux also is there to enforce access controls. And we need to make sure turn off uh, like unnecessary features, okay, whatever the features which is not using. And we need to avoid mounting sensitive host directories. And what goes wrong if we ignore this particular secure defaults was like leaving defaults untouched can expose your host to privilege escalation, and container breakout may also happen, and unauthorized access to your ecosystem and existing resources will happen. Okay, and this is all about D04, which is secure defaults. And moving to the next Docker top 10, which is D05, that is security contexts. Okay, so basically in the security context we are going to like talking about controlling a container privileges by using security contexts. Okay, so the associated risk with this security context was the container running with excessive privileges can escape the container. Okay, so let's say if containers run with too many privileges, like full access to the host, it can obviously break the isolation and compromise the host system also. So this is especially risky with if you use hyphen privileged argument in the command. um, and coming to the associated solution for this context security, security context, we need to use security context to limit a container capabilities. That means security context that will basically define what a container can do and what a container cannot do. Okay, and by restricting the capabilities we can reduce the risk of the container to escape or to misuse the services. And coming to the some best practices, that means we need to drop all like capabilities, run as a non-root user using read-only file systems. So these are the some best practices we need to be followed. And coming to the what happens, what may go wrong if we ignore this security context. By ignoring the security context obviously means containers may access host resources and modify the file system, which have sensitive data, and escalating the privileges and leading to a full system compromise also. Okay, so that is all about security context. And moving to the next Docker top 10, which is D06, protect secrets. So here the associated risk with if we don't protect secrets was uh, protecting secrets, basically how inside Docker container we are handling the secrets. Okay, so associated risk was hard-coded secrets in images expose some sensitive data. Okay, so this will basically brings a risk. And if I wanted to explain more about that particular risk, if you like, let's say embedded if you have embedded passwords or some API keys or some tokens, you directly put into a Docker file or images, they can obviously visible to anyone who pulls that particular image or inspects that particular image. So this basically leading the data to breach or some unauthorized access is happening, right? So that is the associated risk here. And coming to the solution for this risk was by using a proper secret management system and runtime injection. So instead of hard coding those like secrets and passwords, but use some secret management tools like Docker secret, Docker secrets also future is there, and HashiCorp Vault or AWS Secret Manager, Kubernetes secrets. So and also inject secrets securely at runtime, so they are never stored in the image and can be accessed to others, and there is no unauthorized access. And coming to the best practice, never include secrets in Docker file. Use Docker secrets or some external vaults. Okay, so and also limit the access to the particular secrets wherever you store by using role based access controls and audit usage also. Okay, by that you will get to know if some unauthorized user tried accessing that. Based upon that you can trigger alerts, and logging mechanism will be maintained. And coming to the like what can go wrong if we ignore this particular project secrets. So hard-coded secrets can be leaked through the like version control and image registries also, image registries especially like Docker Hub or AWS ECR, like that. And once exposed, the attackers can access the database and some whatever the cloud services or internal APIs obviously. Okay, so this is all about D06, which is project secrets, and sorry, protect secrets. I think sometimes I pronounce wrongly, which is project secrets, which is the correct one was protect secrets. Okay, and coming to the next one, which is D07, that is resource protection. So here the resource is basically uh, how containers can affect system reliability in uh, let's say if the resources are unchecked, how can it affect the system? Okay, and performance and reliability. Okay, and the associated risk for this was containers can consume all available system resources. So by defaultly the containers can use like much CPU memory or disk input output as they want. So if one container like misbehaves or get exploited, uh, it can like affect the others also. Okay, so that is the like main associated risk here. And the solution for the resource protection was we need to set a like a CPU and memory usage by using a argument docker run. I mean, whenever we are running a container, docker run hyphen hyphen memory is equals to, and specify the like limit of the memory in double quotations, like 512 MB, 1024 MB, like that. Okay, and CPUs, like how many CPUs, one CPU or two CPUs, like that. Okay, so that is the solution for that. And the best practice was we need to use C groups, uh, limits and monitoring to prevent a resource exhaustion. Okay, so basically Linux C groups enforces these limits, like combine them with a monitoring tools like Prometheus and Grafana to detect spikes in the traffic and resource utilization, and we can prevent the outages. Okay, and what can go wrong if we ignore this particular resource protection was there will be a chances of like affecting the performance. Okay, so and there will be a chances for denial of services also if we like do not use resource protection. Okay, so that is all about D07, which is resource protection. And coming to the next one, which is Docker OWASP top 8, D08, that is image integrity. So basically in the image integrity, uh, like how exactly um, image pull and run. Okay, so that is all about image integrity. And the associated risk was like tampered or malicious images can compromise system. Okay, so let's say if I wanted to explain more about this particular risk, if an image is modified or comes from an untrusted source. Okay, it might contain some malwares or some backdoors or some outdated components. So running such images can compromise your entire environment. That is the associated risk. And coming to the solution was we need to make sure to verify the signatures and use a trusted like registries. Always pull the images from verified trusted registries, and use a image like signing to ensure what you are pulling is exactly what you published. Okay, I mean what was published is exactly what was pulled. Okay, and no tampering in between. That is the like main thing you wanted to consider. And the best practice was we need to enable Docker content trust and scan images before the deployment. So like by turning on the Docker context trust, that will basically enforce the signature verification. Sorry, signature verification. And whenever we are using the images, we need to make sure to scan the images for vulnerabilities before pushing it into a production, especially. Okay, and what can go wrong if we ignore this image integrity was there might be a unknown like compromised images will be there, and the data leak may happen, and that may install some suspicious malwares or some backdoor activities, and that will basically bringing our entire ecosystem into a trouble. Okay, so that's all about image integrity. And moving to the next one, which is D09, which is immutable paradigm. So basically what exactly this immutable paradigm was, uh, how the immutability um, works, okay, and how that will affect the container security, okay. And the associated risk in this immutable paradigm was mutable containers can be modified by attackers, okay. So this is the target. Immutable paradigm will be maintained as a Docker security, okay. So um, if like the associated risk we are discussing, let's say if containers allows changes at runtime, like writing to the file system or installing some packages, they become obviously vulnerable, okay. So attacker can inject some malicious code or tamper with the environment at the runtime. So that is the associated risk here. And the solution for this was we need to use a immutable infrastructure and read-only file system. So we need to design containers to be unchangeable after deployment. So we need to use read-only file systems and avoid some runtime modifications. So this will basically limits the attacker's ability to alter the behavior at the runtime. So immutability will be maintained. And coming to the best practice was like rebuilding a container instead of patching, okay. So instead of patching we need to rebuild and use a distroless images. So what exactly this means was instead of patching a live container, we need to rebuild and redeploy that particular container into the environment and use a distroless images that will basically exclude the packages, uh, package managers and shells that will reduce the attack surface basically, okay. And what may cause the like wrong if we ignore this particular immutability paradigm maintenance was it can silently alter the content, okay. And it will become very hard to detect the breach also, okay. So they also complaint very complicate for auditing and rollback updates and that will increases the operational risk also, okay. That is all about immutable paradigm, okay. And moving to the next one, that is logging, okay. So here, which is Docker WAP's top 10 logging, okay. So here logging is basically one of the most essential pillars of a container security, which is maintaining a logs, okay. So associated risk for this was without proper logging mechanism, security incidents can go undetected, okay. So we need to make sure, let's say if we don't log a container activity or whatever the activity is happening in a container, you obviously won't know, like if something goes wrong and attackers misconfigurations or failures can happen silently without any notification or alert, okay. And the associated solution for this was implementing a comprehensive logging and monitoring mechanism. So by enable, basically this will enable a logging at the containers and host and some orchestration level also, so that monitor logs in real time, that will help to detect a suspicious behavior and helps us to quickly respond on those activities. And coming to the best practice was a log security events, use some centralized logging mechanism and monitoring anomalies. So by using tools like ELK stack or Grafana, where that will maintain a centralized logs and that will help to track the security events and access patterns and anomalies can be detected across the containers. And coming to the what can go wrong if we ignore this particular logging was like without these logs you can obviously lose the visibility what is happening and who is accessing, what is going wrong, and breaches go unnoticed, and troubleshooting obviously becomes uh, a guesswork. You need to guess what is going to be happen, and compliance audits become very tough and impossible also if we don't maintain logging mechanism. Okay, so yeah, these are all about WAP's Docker top 10, which we have discussed about logging, immutable paradigm, image integrity, resource protection, protect secret, security context, security context, secure defaults, network segmentation, patch management strategy, secure user mapping. Yeah, thank you so much for watching the video, and in the upcoming videos we will be deep diving into each and every vulnerability in depth, okay, and associated in depth information, what is included, how we need to use the commands to make sure to complaint against these vulnerabilities. And also I will provide the WAP's top 10 list in the description, this particular GitHub URL link. By that you will be also keeping this particular information handy, okay, and having great learning, and stay tuned for more videos. Thank you so much for watching the video.